I know that since this is 90 degrees, I'm cutting it in half into a 45, 45, 90 triangle. Does anyone remember how I label a 45, 45, 90 triangle? How do I label the sides of it? Yeah.
You have two sides and one side is for two.
Yeah, so we'll have something like S or whatever one you want to use, S, and you said whatever that is, and do S square root of 2 would be your hypotenuse. So since S squared of 2 is the same thing as that 9 squared of 2, you could go, well, S squared of 2 must equal 9 squared of 2. Divide both sides by square root of 2, and you find out that S equals 9. Well, that means both of our sides of our square are 9. So our area is just going to be 9 times 9, which equals 81, which you could add a unit on to remind yourself that if there was a unit, you'd square it. So I'm just going to put it as 81 units square. On the test, I'd be okay with 81. Unless I said they were centimeters, then you must put it centimeters squared. All right, that is the area of that square. All right, a rectangle, we have a base of 12 and a diagonal of 13. So let's draw that bad boy. Let's say this is 12, and it says it has a diagonal of 13. Now, don't try to push things into a 60, 30, 45, 45, 90 triangle. Don't force it into it. Ask yourself, do I know two sides of the triangle? Yes, I do. If you know two sides of your triangle, how could I find that third side? Aryan? You could use primitives. That'd be a great one. What would it be if I was looking at Pythagorean triples? It would be 5. Yeah. So in fact, x equals 5. What if I didn't realize it was a Pythagorean triple? What would I do to find x? Hamza? Just a Pythagorean theorem. So we could do x squared plus 12 squared equals 13. But Aryan said, well, hey, I realized that was a Pythagorean triple, so I can jump right to the fact that x equals 5. We all get the same answer. It's just one person's done right away because they realized that it was a Pythagorean triple, and someone has to do a couple extra steps. But long story short, our x should be 5, which means this rectangle has a height of 5 and a base of 12. So our rectangle is going to equal, the area is 5 times 12, which is going to equal 60, I guess, units squared, if you want to remember that it would be units if it had units. Questions on either one of those two? Okay, let's go with questions from the homework. Questions from 11.1. Brendan. 32, was that the last one? Yeah. All right, 32. We have 3 squares. We have 3 squares they're talking about. One has a length s, one has s plus 1, and one has s plus 2. So let's draw 3 squares. 1, 2, 3 squares. So one of them has a base of s, one has s plus 1, one has s plus 2. Well, they're squares. The one cool thing about squares is all their sides are the same. So if we look at that first square, it'd be an s by s. The other one would be an s plus 1 by an s plus 1. And the other one would be an s plus 2 by an s plus 2. So let's quickly calculate the areas of each of these. Well, the area of this one would be s times s, which would be s squared. The area of this one would be length times width, which would be s plus 1. Make sure you leave it in parentheses. Times s plus 1. That'd be the area of that one. Then this last one would be length times width, which would be s plus 2 times s plus 2. Those are all the areas, because it does say the sum of all the areas equals 365. Is that right? 365 on that one? 365. All right, so when I add all these together, they need to equal 365. All right, well, that's just an equation. That's an equation where I have s squared plus... Now, remember my hint for a binomial times a binomial you kind of struggle with, because I know they have like FOIL, first, outside, inside, last. What I always do in my head, especially when it gets to bigger ones, is in my head I'm thinking, okay, I need to distribute this s to both things, and I need to distribute this 1 to both things. So this one would be s squared plus s times 1, which would be s. Then distributing that 1, I would have 1 times s, which is s, plus 1 times 1, which is 1. Do that same thing for this one. We'd have s times s, which would give me s squared. Then we would do s times 2, which would give me 2s. Then we would do 2 times s and 2 times 2. So that's going to give me another 2s. Plus 4 equals 365. Just so you're not watching me do all of this stuff, when you simplify all of this, it will reduce down to 3s squared plus 6s plus, hang on, minus 360. So it'd be 6s minus 360 equals 0. Now, the only way to solve that is to factor it. But there's one thing you can do to make the factoring easier. Hamza.
You could simplify all the sides by 3.
We could divide both sides by 3. Take 3 out of all of these. So we're going to divide both sides by 3. 0 divided by 3 is still 0. So we're going to end up with s squared plus 2s minus 120 equals 0. When you factor this, you're going to end up with x plus 12 times x minus 10 equals 0, which means either x equals a negative 12, which doesn't work. Ooh, I changed it to x's. It should be s's. Sometimes I do that. I like x's better than s's. All right, for this one, we'd have s equals 10. 10 works. So I'm going to plug 10 into each of these to figure out the areas of the individual ones. Did that answer your question, or did I skim over something that was important? You sure?
Yeah.
Okay. Other questions? Hamza.
For number 20, I got 140.4 because I didn't do it.
So yes, that is correct, because you used sine, cosine, or tangent. You used some kind of trig on it, right?
Yeah.
I used the exact, you used trig, so you rounded at some point, which means your answer is going to be slightly different than mine, but that is correct.
Okay.
Be careful, though. Make sure you know how to use 30, 60, 90, because I could on the test say give the exact value, in which case you'd have to use that square root.
Okay. So we can't use trigonometry.
I didn't say you can't. I just said if I said it, you need the exact answer, that means you need to use the 30, 60, 90 rule.
Okay.
All right. It's good to know trig because you can use it across the board on anything. But it's also good to have in your pocket the 30, 60, 90 and the 45, 45, just in case you need a more precise answer.
Okay.
Other questions? I just want to be clear. On number 20 and 22, 20 or 22, you might have got a slightly different answer if you used trig. Hamza.
On number 13, I got a squared minus 9.
On number 13, you got, say that again?
A squared minus 9.
Yeah, that's what I got.
Oh.
I just have as a squared minus 3 squared,
okay.
which is 9.
Okay.
Yep, I should have simplified that. I did not. But we have the same answer. Other questions? Okay, today we're going to talk about the areas of some other figures. The good thing is every one of these is basically based upon rectangles. First one is parallelogram. Remember, a parallelogram has opposite sides that are parallel. So make sure when you are dealing with something that you think is a parallelogram, make sure it says it's a parallelogram or it has a picture supporting the fact that it is a parallelogram. There are shapes that look like parallelograms that aren't parallelograms. All right, so we're talking about things that are specifically a parallelogram. Well, I'm going to draw something on here. I'm going to draw a height. Now, to be a height, it has to hit 90 degrees on an opposite side. So it goes from an angle, or it goes from the top and bottom and creates two 90-degree angles. That is going to be a height of a parallelogram. It creates two 90-degree angles. Well, what I want you to look at is this little section right here. I'm going to kind of color it in. Let's color it in, I guess, purple. Look at that little section right there. If I took that little section right there and I said, cut, paste. I'm going to paste that little section right over there. what does that look like? Yeah. Not a square, but a rectangle. It could be a square if it was. Well, guess what? A parallelogram has the exact same area of a rectangle. Because if you take this little piece and you copy and paste it, it actually makes a rectangle. So this is going to have the same exact area of a rectangle. As a rectangle with the same dimensions, where this is our length and this is our width. However, with parallelograms, we don't call it length and width, we call it base and height, where this is our base and this is our height. So the area of a parallelogram is going to equal the same thing as a rectangle, which is just base times height. Think of it as being height rather than width, because sometimes people get really confused at this being a width, because it's much easier to picture it as a height, especially with the 90 degrees on it. So that is a parallelogram. You just need to know the base and the height, and you now know the area of a parallelogram. Let's go down to example 1. Example 1 has 2 parallelograms that I find. The first one I find really interesting. It says, find the area of the parallelograms shown. Your height is not always just up and down. I can draw these shapes however I want to. So if you could, just take your sheet of paper and turn it sideways where 6 becomes your base. You will then notice that this goes vertically up and down. So even though it's going this direction, as long as it's creating this 90-degree angle on our parallelogram, this has to be a height. So that 8 is, in fact, your height. And I know it's a height because it's based upon this 90-degree angle. That 90-degree angle tells you it is the height of your parallelogram. If that's my height, that makes 6 my base. And like I said, the area of a parallelogram just equals base times height. As long as you know both of those, you know your area. We said our base was 6, and we said the height was 8. So it's going to be 48 units squared, because they didn't actually give me any units. Hamza.
Doesn't the height have to have 90 degrees on both sides, though?
It does. It really does, because it's a parallelogram. Mm-hmm. And since it's a parallelogram, this line is parallel to this one. So alternate interior angles would make this 90, which would make this 90 as well. So realistically, for a parallelogram, you just need to see one right angle, because the other one has to be, because it's a parallelogram. It carries those rules with it. So you just need to see one of them. I know I circled both of them here, but just know if you have one of them, the other one exists as well, automatically for a parallelogram. So you're just looking for one right angle. I'm glad you asked for that clarification. All right, I said you just need to have a base and a height. What's the base of the next parallelogram? Sam?
5?
5? It's not 5. Yeah. It's 10. It's your whole length. This is your base. The only thing you're missing is your height. Your height's the one that creates a 90-degree angle. I see what you're trying to do. You're kind of cut it in half. But just remember, your base is that entire length. Your base is always going to be the entire length. We don't have to overthink it and go, oh, I got to cut some stuff off. Your base is just your base. So that 10 is our base. Actually, glad you said 5, because people do that all the time on tests. They cut it up because I do this drawing, and they're like, I'm so used to cutting it in half. For bases, we leave alone. All right, so the only thing I need to get is that height. Well, that height is based upon a 90-degree triangle. Let's pull out that 90-degree triangle. Remember, height creates that 90 degrees, where we have 45, 45, 90. And we know the hypotenuse is 8. I think it was Cam that told us that it's going to be s square root of 2 for that 8. For a quick recap, if s squared of 2 has to equal 8, that's what we're going to put over here. We'll say s squared of 2 equals 8. We'll divide both sides by square root of 2. S is going to equal 8 square root of 2. Is 8 over square root of 2 simplified? Can someone tell me how to simplify it? Cece? Yeah, multiply by radical 2 over radical 2, which is actually going to equal 8 radical 2 over 2. Simplify that a little bit. 8 divided by 2 is 4, so we're just going to have s equals 4 square root of 2. Well, that means our height, which is that s, is going to be 4 square root of 2. So our height is 4 square root of 2. Where do you know the base is 10? I just needed to find the height was 4 square root of 2. So our area is going to be base, which is 10, times that 4 square root of 2, which equals 40 square root of 2. That says 4. I meant to say 4d square root of 2. There's no units on it, so I'll just put units squared. Yeah, go ahead.
Could we just enter it into our calculator and have like a decimal? Or
Yes, but I would like you to know how to do 45/45s, because like I said, if on a test I was just like, you have to give me the exact, you have to know that method then. All right, so it should be something you have in your back pocket. If I don't ask for the exact answer and you like using trig, then just use trig on it. Other questions? All right, the next one, we're not going to spend a ton of time on it because it seems like most of us know this one. Who could tell me what is the area of a triangle? Yeah. 1/2 base times height. I'm just going to spend a couple seconds talking about it, and we'll talk about why it's 1/2 base times height really quick. So I'll make a little line here. If you ever have a rectangle is length times width, but if I draw a triangle in it, that's half the size of your rectangle. A triangle will always be half the size of a rectangle you draw around it. That is where that 1/2 comes from. So in fact, your area of your triangle is 1/2 the size of a rectangle. And that's really where it comes from. Half a rectangle is a triangle. Every triangle is half of a rectangle. It's important to realize that because we're going to use that fact later on. All right, but that's area of triangle. We've seen that a lot, so I'm not going to dwell on it too long. I picked this one in particular because if you remember when we talked about altitudes, your height does not always go through the center of your triangle. In this one it will, in this one it won't. So let's do this one first. It says find the area of a triangle with sides 5, 5, and 8. If I'm on a test and I don't know how to do it, at least I can draw a picture. Let's draw an accurate picture as we can. What kind of triangle has two sides that are the same? Arya? It's an isosceles triangle. So I'm going to draw something that looks kind of like an isosceles triangle. So I'll draw two that are about the same and a base. And we'll say that's 5, 5, and 8. All right, the area of a triangle is half our base times our height. I need a height, so let's draw a height. A height goes from the vertex to a 90-degree angle on the opposite side. Now, just so you know, depending on how you draw your height, depends on what your base is. Your base and height are always going to form perpendicular lines. So the one that's forming the perpendicular line is going to be your height and base. You can't just pick one of the numbers to be your base and then go from there. This height tells me that this 8 is our base. All right, our 8 is now our base. Well, one of the rules we have for an isosceles triangle is the altitude actually splits our base in half. So that means I have 2 right triangles that I'm going to form. So let's pull out this triangle here. Pulling out this triangle that has a 4 and it has a 5. What is the height of this triangle? It is the most basic Pythagorean triple there is. Ishana?
3.
It is 3. It's a 3, 4, 5. Would it matter if I did a squared plus b squared equals c squared? No, it just takes a little bit longer. Don't feel bad if you have to do a squared plus b squared equals c squared. It just takes a couple little extra time. But just because we know it's a Pythagorean triple, I'm going to say, well, that must be a 3. That has to be a 3, which means my base is 8. So I'll have half of area equals half of our base, which is 8, times our height, which is 3. Well, that's going to equal 12 units squared. Don't let me confuse you here. So if what I'm saying doesn't make any sense to you, just forget I said it. If you're ever dividing a triangle in half, the area of this big one is just going to be 4 times 3 because I already have half the base. Half the base times the height is your triangle. So I could have just went, oh, this is already half my base. I can just do 4 times 3. Don't let that throw you off, though. All right, the next one is just interesting in how it's drawn. In this case, our altitude is outside of our circle. It doesn't run through the middle of it. That doesn't change the fact that it's still a height, just because it's outside. The definition of a height is it goes from the vertex to the base and forms a 90-degree angle. Does it go from a vertex? Yep. Does it go to the base and form a 90-degree angle? Yes, it does. So even though it's outside of that triangle, this is still our height. If that's my height, the one that forms a 90-degree angle with it is going to be your base. In fact, I could have called this my base and this my height as well. The definition between them are fuzzy. They just create a 90-degree angle between the two. So this could have been my base, this could have been my height. It fit all the definitions, depending on how you're looking at it. Like if I turn it sideways, you're going to go, okay, that's my base and that's my height. And so now I know my base and my height. So our area is just half your base, which is 22, times our height, which is 15, which is going to equal, well, half of 22 is 11. So you have 150, 165. Did I do that right? Yeah. Centimeters squared. So just ask yourself, is it a height? All right, heights create 90-degree angles. Sometimes they're outside. Sometimes they're away. Sometimes I'll put a little mark right here and says this is 15 degrees. And I'll put a little right angle over here. All right, questions on either one of those? Okay, the last one is just kind of the opposite direction. We're given that the area of the following triangle is 60 centimeters squared. So remember, that would mean that area equals 1/2 base times height. Well, my area is 60 in this case. Equals 1/2. Well, height and base make a 90-degree angle. There's a 90-degree angle on here. That means I can call 8 my height or my base, and I can call this h my height or my base. Whatever you pick for one of them, just pick the other name for the other one. So let's go ahead and call 8 our base in this case. That's going to make h my height. Once again, they're forming a 90-degree angle, so we have a base and a height. All right, so we have half of base times height, half of 8 times our height, which is h, which means I need to solve for h. Well, let's just do this 1/2. So I'll have 60 equals 1/2 of 8, which is 4. H. Divide both sides by 4, and we're going to have h equals 15. It is just regular centimeters because it's a length. It's not the area. All right, just one more shape. One more shape. I know we're doing a whole bunch of examples, but each one's slightly different and it'll help you in the homework and in the long run because we're going to start getting really complicated ones. All right, the next one we're going to talk about is a rhombus. At its heart, a rhombus is a parallelogram, which means finding the area of a rhombus is the exact same thing of finding the area of a parallelogram. So remember, this is just a parallelogram. And so the first way to find the area, if I know the altitude, is just going to be base times height. I guess I'll actually put it in there. Base times height. It's the exact same thing as a parallelogram. If I would cut that little triangle off, so if I would draw a little triangle here and cut that off and put it over here, I'd once again have a rectangle, so this one would be S times the height. I want to keep this clear, though. This S here is not the height. Don't get that confused. Your height has to be that line that forms this 90-degree angle, so I don't know the height on this one. I just know it's the altitude there. All right, so that's the one rule with rhombus. Now, a rhombus is a very specific parallelogram in that all the sides are equal. All of the sides are equal. So there's another formula for the area of a rhombus. And this one is if you know both of your diagonals. If you know both of your diagonals. And what's going to lead us to this is drawing a rectangle around it. So I drew a rectangle around this particular rhombus, where the length of the rhombus, I'm not the rhombus, but the length of this rectangle would be diagonal 1. And the height of this rectangle would be diagonal 2. So if I asked you for the area of the rectangle, so the rectangle area would equal diagonal 1 times diagonal 2. But the rhombus is smaller than this rectangle. And let's see how much smaller it is. If you look at just one of these rectangles, if you look at just one of those little tiny rectangles, and I look at the information that I want to have, how much of this rectangle is taken up by this triangle? Yeah, half. How much is this one? How about this one? How about this one? So I'm doing half of each of these little tiny rectangles, which means our rhombus is half the size of that rectangle. So the rhombus area is going to equal 1/2 the rectangle, or 1/2 diagonal 1 times diagonal 2. So if I know both of the diagonals of a rhombus, I'm going to use this formula. If I know the altitude, then I'm going to use this formula. Altitude or height, know the diagonals. You have to know the difference between these two. There are going to be lots of occasions where I give you rhombuses and I give you one information or the other, and you have to pick which one to use. In fact, that is our next example. Our next example does not give us a height or an altitude. In fact, they give us one diagonal length. What is the length of that one diagonal?
8.
Yeah. It would be. That's part of it. What's the diagonal that's listed for me right now, though? It's 8. Yeah. All right. With the rhombus, the diagonals always intersect at a 90-degree angle, always. So if I give you, now pay attention to this, because there's going to be ones where I just say a rhombus has a diagonal of 14, what's the other diagonal? You have to know that this is 90 degrees. If you forgot that, that is something to write here. You have to know that. All right, so that makes 90-degree triangles. So we have this triangle here, which creates a 90-degree angle. We have 4, 5. That missing section is what Isabella said, is 3. That is a 3, 4, 5 triangle. So that 3 goes there. That 3 goes there. So our other diagonal, our diagonal number 2, is going to be 6. Well, the area of a rhombus equals 1/2 diagonal 1, which is 8, times diagonal 2, which is 6, which is just going to be 4 times 6, which is going to be 24. I don't think they gave me centimeters. No, so we're just going to say units squared.